The circuit with a transistor is the easier one. You can settle for the one without, because apparently the transistor lesson is not posted. So it's a bit more the circuit with the transistor is a bit more complicated, but settle with the one without the transistor. It'll work the same way, but we'd rather have the transistor there for other reasons. But for this application, it's fine.
Should we build this now?
You could.
Okay.
But it's gonna take a little bit. So let's look at Courtney as she records this lesson and works through
Yeah,
the
let's go through the code first.
You can always go over this later. So
Okay.
I'll stop. So Courtney, let me know if you're ready to share your screens.
Yeah, I am ready.
Giving everyone the last sec to hold on. Giving everyone the last sec to screenshot this.
Hold on, I was going to reference something from this.
Oh, okay. Keep going.
Yeah. So I'm sure like what you guys have noticed is that for the Arduino right now, we're using some of the analog pins and some of the digital pins. And so we're going to go over a little bit about how those differ and how the Arduino like sees the signals on those different pins, because there is the Arduino isn't able to completely handle everything that we might throw at it. And we're going to do that through code. And the point of this circuit is that based on the temperature, the LED is going to change how bright it is. And that will be done through taking analog and digital signals and changing things up based on those values. Okay, I have referenced what I need to.
Yes, okay. I'll now stop share, get ready to share your screen.
Oh, do I even have oh, I do have a share screen.
You can only share the window, so it doesn't share the entire screen.
That works for me. Okay, so the way that analog signals work, so for example, the thermistor that is in this circuit, that gives out an analog value. And so it could give out nothing. It could give out, it's connected to 5 volts. So it could give out the full 5 volts, which would be like up here. Or it could give any value in between. And the analog pins on the Arduino can read all of those values. It takes however much between 0 and 5 volts, and it can read that value. However, the digital pins, it can only read, this isn't a very good visualization of it, but it can read the 0 value, or it could read the full 5 volts. But anything in between, it's not going to be too sure about. It might, like if it's 4.7 volts, it might say that's close to 5, and so it's going to accept it as the pin turned on. Or it could just see, maybe it's only 1 volt, and it might interpret that as no, that pin is probably off. So digital, it's either it's on or it's off. However, the Arduino, while the analog pins on the Arduino it can read analog, it can't output analog signals, but it can input and output both digital signals. And so we have to do something to make, if we want to output an analog signal, for example, to make the LED go brighter or dimmer, we have to do some work to make it look like an analog signal. And so the it would end up being interpreted something like this. I think, yeah, there we go. And so the way that this little trick, it's called pulse width modulation, or PWM. And so in a given set of time, so between these green lines, imagine that's like one cycle. So the Arduino only, it can output things in this much time as like one cycle. And if you have this entire cycle filled up where the pin is on, that's that would be like having the LED turned on. Whereas if it's off, the LED would be turned off. But the Arduino, what it can do is we put the pin on for just a fraction of that cycle, and then it stays off for the rest. And so then it's through that variability of how long the pin is on for that cycle, it will start to mimic the analog signal. And that's where we get this type of, it's a digital signal, but it looks like analog. Because, for example, in this little rectangle here, it would, the pin would be on for only a fraction of a cycle, whereas the pin here would be on for almost the entire cycle. And there's a way to do that through Arduino code. So I'm gonna open up my Arduino editor to show you guys what the code looks like for this. So in Arduino code, there's two parts of the code. There's the setup, and then there's the loop. And the setup, it's kind of just before we get started, here's some information, while the loop, that's the main part of the code. Oh, I should just check. Does anybody have any questions yet? Nope, doesn't seem like there's any questions.
Cool. Just for information, there will be more information posted on analog to digital and also PWM. We have videos online that with further explanation on the topic.
Yeah, those videos are 2 hours long, so I'm trying to give you guys kind of the quick version.
Mhm.
Because you can spend an entire 2 hours learning all about it and more. Okay, so back to Arduino code. So if you look at your Arduinos at the analog pins, you'd see that they're numbered between A0 and A5. And what we want to do is we want to tell the Arduino which pin we want it to read. So here, I'm going to give it a value, telling it like the thermistor pin is A0. That's what I have mine plugged into. You guys could do whichever pin you want. And so I'm because it's going to be the same throughout the entire code, I put it as a constant right up at the top. And then in the setup, serial.begin on the 9600 port, that's you always want that because you need to have a port open so that it can do the stuff. I don't have a better explanation for that, unfortunately. It's just the way Arduinos and code work.
I can help you out.
Yeah?
It's It's typically serial.begin. Serial calls for the serial monitor. So if you want to output something into the serial monitor, that's how the Arduino sets it up. And the baud rate is 9600. So what that means is it's the speed in which your computers, the serial monitor in your computers communicating with the Arduino. So that is 9600, I think, megahertz. Not too sure the scale, but it's 9600. So that line of code is typically just the speed in which your computer and your Arduino communicates. Make sure they are in the same language, in the same wavelength.
Right, I remember that now.
Yes, Gabe explained that as well in the lectures, and that's the first time I learned it there. And Gabe explaining in the lectures of the YouTube videos. They're great. Just go watch them.
Yes, yeah, the videos, the YouTube videos on that are linked, they have a lot of really good information. You could watch them 5 times and learn something new every time. All right, so on to the next line of code. We have pin mode. And so what pin mode does is it has two inputs. The first input in the function is which digital pin you'll be using. And so, for example, my what's it called? Transistor. It's hooked up to the digital pin 5 of my Arduino. And so I want to set pin 5 and I want to send signals on that pin. I don't want to read them. I want to send something out. And so then I label it as an output. If I wanted to read a value, I would have it set as input. And then, so what you could do with Arduinos is you could have it float high or float low. So like I explained earlier with digital pins, they either read as off or they're turned on. And so you can have it so that the pin is, if it's not in use, it's going to like float at high. And so for example, if you want to have a button and when the button is pressed, your LED turns off, you'd want to have the pin floating high. And if you don't want to put this line in, it defaults to low. So this line isn't completely necessary. And now onto the main loop. So Arduinos use embedded C. And so if you guys have taken CMPD 130 or 135, it's going to be really similar to what you learned there. So you can declare an int, and I have one called sensor val. And what it's going to do is it's going to take the analog reading from the thermistor pin, and I'm going to take the modulo of 255, which I'll explain in a minute what that means. But analog read, it means that I'm going to read an analog value. So it's going to be any value between 0 and 5 volts. And the Arduino knows to expect this. And in the parameter of it, I tell it which pin to listen to, which is going to be the thermistor pin, which I've told the Arduino is analog port 0. And so here's where the pulse width modulation function happens. There's a function that you can give your Arduino that's called analog write. And what that is going to do is it will take digital signals and it will turn it into a pulse width modulation type of signal. So it will either have the pin on or off, and it will have it for a certain amount of time. And the value that you can give it to tell it how much time to be on and how much time to be off is anywhere between 0 and 255. That's why in the previous line of code, I had modulo 255, because I can only give it up to 255. And so I want to take in C, the modulo stands for the remainder of a division. And so it's going to make sure that I don't have any values that are over 255. In analog, right, the first parameter says which pin it's going to be on. So it's going to be, and because the Arduino can't output any analog signals, it can only do that via the PWM of the digital ports. You don't have to worry about specifying if it's A0 or if it's a digital, because it's always going to be digital. So I have mine plugged into port 5. And so I say analog write to port 5. So it's going to give me a PWM value on port 5. And then the value is going to be 255 divided by whatever value I read in the line above. And another thing you can do is you can just delay how long, or if you want it to wait before it does another loop, you can just give it a value. 1000 is equal to 1 second. And so it goes a little bit slower. And so what this entire loop is going to do is it's going to read the temperature based on the thermistor value, and it's going to use that to change the brightness of the LED. All right, and that is our intro to programming with the Arduinos. Does anybody have any questions? Does everybody understand what we just went through?
For the most part.
Awesome. All right, I will stop recording then.